Okay, so now we'll actually start. So if somebody misses class, again, you guys that are joining us for class today, I like to have you have your cameras on so we can see if there's a real live person there, and then we can have some interaction. We were talking before class a little bit about, and if you're eating, that's no big deal. I've got my English muffin with peanut butter on it still sitting here. I didn't even get a chance to eat it. So yeah, we're just talking about, well, we were talking about the space flight thing, which actually, it hardly even counts as a space flight. They just go up and then kind of come back down. But it's still it's pretty interesting to that, the technology has evolved where we've got that going on, and the reusable boosters is pretty cool too. If they can have that thing come back down and land, that's a pretty big deal, as opposed to having something that just sort of burns up or falls into the ocean. So
well, the networks that NASA or like Amazon and all that stuff, I guess, is a little relatable of like how the data and
oh, for sure, yeah, it's all technology related. I mean, they're using it's in the drone shots were pretty cool that they had this morning. But like I said, I was expecting more shots from inside the capsule, like what was going on inside, and it is a fairly short flight, but I wanted to see them. They get to get out of their seats for a second, so I kind of wanted to see. I missed part of it this morning, but I don't think they had that. I wanted to see Shatner up space being weightless for a second. So at any rate, what I wanted to get feedback from you guys, we're into like the second week of the quarter. You guys have a small assignment from chapters 1 and 2, just 20 questions. Are you guys doing okay with those? They're due tomorrow, I believe. Everybody get them done?
Yeah, I got it done like last week. Just kind of
yeah, there weren't a lot of them. We'll have other assignments. The other questions from the chapters, I just chose the true false for those, but you guys will have some that are multiple choice and stuff like that. And the idea is just to give you some impetus to read the book a little bit. I guess so, a push in the right direction to read the book to answer the questions. But I also would encourage you guys to use the chat thing in Discord if you want. You can talk to each other in there under class discussion. If there's, if you guys have a question about any of the questions, ask each other for help. I don't mind that at all. You guys have the books, you can Google stuff. Now the book tends to have the questions somehow, in word for word somewhere in the chapters. So that's really the definitive answer. Sometimes for certain things, sometimes you'll get conflicting views. Like for instance, like a network card, is that operating at layer 2 because it has a MAC address, or is a network card layer 1 because that's where the cable actually plugs in? Well, it kind of bridges that gap there, and you'll get different answers on that kind of stuff too. So
yeah, and in the book they, or the author explains how it kind of gets blurred, and then he's like, well, technically.
Yeah. I mean, it's again, it's one of those weird things where you've got, and that was just an example, in terms of if you're Googling something, you might get one answer, versus if you're using the book, which is where the questions come from, that's going to be the definitive answer, at least for the quiz. That's but for you guys just talking about it, I would encourage you guys to talk to each other. That's part of the deal. If you were here in class, we'd be talking about William Shatner in person this morning, having coffee, maybe some cookies or something. But you guys can talk to each other about the quiz. Just as a reminder, it is due tomorrow. So if you haven't done it yet, there's only 20 questions. You can bust them out pretty quickly. So make sure you get those turned in, obviously. So, but I wanted to get some feedback from you guys this morning too, in terms of our Zoom schedule. I'm used to teaching face-to-face, but we've been doing the online stuff for a few quarters now. And is the Monday, Tuesday, Wednesday schedule working for you? Do we want to mix that up a little bit? Taylor,
it's working for me really well.
Okay, Taylor gave me a thumbs up. And sometimes once we get into a schedule, I know some of you guys are working or have kids or families or life actually happening besides school. So once we get into the schedule, some of you are probably starting to plan stuff on Thursdays and Fridays, maybe work or something like that. But I'm open to suggestions. I'm here for you guys. That's why we're here, is for all of you. So if that's enough Zoom for you, that's good. We could do more, or we could do Monday, Wednesday, Friday, but blocking it together gives you, so some, like if we're talking about something like subnetting, for me, it's nice to say, okay, yeah, we were talking about this yesterday, and there's obviously a gap when we hit Wednesday, there's a pretty big gap until Monday. But, if we have some cohesive lecture Monday, Tuesday, Wednesday, even if we skip even if we go Wednesday through and then Friday, for me, there's like a gap in the middle. And then anyway, it's just, I just wanted to get some feedback from you guys. I saw a few thumbs up in the little part, but if I have any, if you guys just wanted to get to know if it was working or not, or.
I can flip flop to whatever, but yeah, it feels kind of cool, like just having it all like, you know, Monday through Wednesday or whatever, 3 days consecutively, and then like go do the rest of life.
Yeah, and it is a bit of a break, you know, to have those days. During those days, I have had some students asking questions on Discord, which that's great. So, you know, some of the students that picked up computers, for instance, there were some questions about resetting the password on the BIOS and things like that. So you guys are always welcome to contact me either on I log into Canvas, but not as much. I mean, I do, but Discord, because it's an app, it just pops up on my phone with a notification. You know, I had actually had a student contacting me that graduated a couple years ago about something else, job stuff. But so yeah, that's pretty convenient. If you guys are on there, get the app, you know, for the computer or your phone, and you can message me or even post a message for the rest of the class if you're asking questions about the test questions or stuff that we're working on. So all right, we're going to go ahead and get started then. We're going to talk just briefly about subnetting today. We'll talk a little bit about the stuff in chapter 2 as well, but hopefully you guys have been reading through chapter 2 with the kind of network infrastructure part of it, talking about, you know, how the network is physically laid out. There is also a piece of software that I had the class download last year, which I think is pretty useful. And I'll put a link in Canvas to it. It's from Cisco. Cisco makes, you know, routers and all that stuff. They actually bought Linksys. So Cisco bought the Linksys company, so they're making, you know, home size routers. So it's called Packet Tracer, and what it is it's a network diagramming tool. So you can diagram out a network, but then you can also switch into this kind of live view, and you can send packets. Like, so you'll diagram it at a network. You'll have like a router, and then a switch, and then a bunch of computers connected to it. And in Packet Tracer, you can then say, okay, I want a packet to go from this computer to this computer, and it'll kind of show what's happening. And the other thing you can do is you can click on the icon for the router, and it'll show you a picture of an actual router, like a bigger one. Let me see if I can find my router back here. It's like, oh, okay, I'll go to the junk pile. And so, you know, if we're at home, you're used to using something kind of like this, maybe with more antennas. We have one up in the fishbowl room that's got like 8 antennas. It looks like a little Death Star kind of thing. But anyway, you're used to home routers. A lot of businesses will have something that's, you know, about like this. Maybe this one's pretty old, but they actually still make this model. But a larger business will have a piece of rack mountable equipment. So they'll have a server rack. They'll have the demarcation point, which we'll talk about in a little bit. That's in chapter 2. And then you'll have some type of piece of equipment that connects you out to the internet. So CSU, DSU type device that maybe connects you to fiber optic. And then that comes into a router. So you'd come into a device that only does routing. This doesn't do switching. This does not do wireless or anything like this. This is an older Cisco 2600 series. And basically, you've just got your outbound port going out to the internet, and your inbound port that would then connect you to maybe another firewall or a switch or something like that. So, you know, rack mountable, bigger piece of equipment, able to handle much higher load in terms of the amount of traffic and things like that. So at any rate, we're going to finish up the subnetting stuff today. So I've got a quick example for you. How many of you looked at the Punky's how-to pages thing that I posted? The website that we had yesterday.
Yeah, I looked at it, still reading it, copy pasted some notes, but still, you know, trying to wrap my mind around how to identify exactly what an IP, you know, what class it is.
Yeah. Okay. So in his first example that we looked at, we were looking at a class C network. Tristan's got his cat, right? Cats are famous. I don't know. I swear cats. Our cat, when my wife is at home doing, like, she'll have meetings at home sometimes too. And the cats, I don't know if they just know there's a camera, but the cat walks up and like he puts his butt right in the camera. It's like he just knows every time. He's just like, oh, you're on camera. I'll stick my butt in the picture. It's pretty funny. So at any rate, yeah, the first part of subnetting is determining the class of address that you are working with. And you can do that, but you can do that by looking at, if you convert the number to binary, it kind of helps as well. Or you can kind of memorize, okay, if it's between, 1 and 126, it's class A, 126 to like whatever it is, 191 is class B, and then like 192. And you'll notice that not all the numbers get used. That's because there's some classes of addresses that were reserved at the very beginning for some experimental purposes. So there is technically a class D and a class E, but they're not used by people, businesses or otherwise. One of them is for multicasting, and then one is like for some experimental purposes, which I'm not, maybe that's the IP addresses they use at Area 51 or something like that. Who knows? Okay, so the first part of the equation is trying to figure out what class of address does your address belong to. So I've got 134.39.00. And when you see the zeros on there like that, then it's a good indication that that is an address for an entire network. It's not just for one computer, it's actually for the entire network. And it may or may not have been chopped up, but probably has not been chopped up if it's got the zeros on there. So the first question is, using your book or Google or whatever you're using, what class of address is this? You only got 3 choices.
Yeah, I think it's class B.
All right. It is in fact class B, right? So you can kind of memorize them, or you can Google it. Tristan's typing into chat class B. Remember, yeah, it was from like, I believe 1 to 126, something like that. 127 is that special loopback address that actually belongs to yourself. Like you can ping 127.001 and it just kind of rolls back on your own network card. So anyway, class B is kind of the middle range. And then you have class C, which are the higher range numbers for this first. You're just looking at the first octet, this first group of numbers here. And so it indicates that it's class B, which then gives us our second thing that we want to know. And the second thing is, for a class B, your starting point, your beginning subnet mask, so that's the subnet mask. Your beginning subnet mask is 255.255.00. So remember, if you converted this into binary numbers, the 255s are 8 ones in a row. So if you add up 8 ones in a row using our little cheat sheet, which remember our cheat sheet, I'll just draw it again real quickly. It starts out with, it's 2 to the 7th, 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and 2 to the 0. So it starts at 128, 64, 32, 16, 8, 4, 2, and 1. All right, so if you add up all these numbers, 128, add up all these numbers with ones, if you had ones in each spot, that equals 255. So that's kind of a magic number, right? So think of the subnet mask, as I mentioned yesterday, think of the subnet mask like kind of like a sliding window, but the window you can't see out of it, or like masking tape. You've got a roll of masking tape and you're sliding there or taping off parts of the numbers. So what the first part indicates, where these are all ones, if you think of 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. If these are all ones, that indicates the network portion of the address. Let's see, you've got some glare on there a little bit, but I've got the windows open. It's such a nice day. It snowed on Mission Ridge last night, so I guess wintertime is getting close. So I'm not quite ready for winter yet. All right, so at any rate, this is our network portion of the address. So you can see right here too, this part indicates the network, and that leaves all of these bits. And remember, each of these represents 8 bits. So you've got 8 bits, and plus 8 bits is 16. So 2 to the 16th power. We looked at exponents yesterday using our calculator. Oh, okay, Tristan's given us a weather report. That's great. You drove over the pass and it's snowing, which is, I guess, cool, but a little scary if you have to travel and don't have your snow tires on yet. So 2 to the 16th power, remember, was 64,000, and some odd numbers, right? So 64,000 addresses for a standard class B network. So what this is also, so if we see the subnet mask, remember you had You only have, so as we get down to this, if you're dealing with standard Class A, Class B, Class C subnets, you only have 3 choices for your standard subnet mask, right? So Class A, the subnet mask, again, representing an entire network that hasn't been chopped up. A Class A is 255.0.0.0. Class B is 255.255.0.0. And then Class C, which we played with yesterday, is 255.255.0. So this one is a /8, this one /16, this one /24, right? So if you're looking at, that's hard to read there. So you've got 8 bits here, 8 ones. This one's got 16 ones going across here. And this one has 24 ones. So I didn't finish that one out. Okay, so that one has 24 ones all the way across. So Class A, not very many networks, but lots of computers on each network. Class B kind of splits it right down the middle. And then Class C, you've got a lot of Class C networks, but each one is relatively small. You've only got 8 bits worth of numbers that you can put out to computers. Okay, so the first step, like I said, is to determine, when you're looking at an address, is to determine where your starting point is. You know, what are you starting from? Are you starting from a subnet mask that looks like this? Or are you starting from one that's a Class C? So you need to know, and for any address that you get, like if you're assigning addresses to stuff like a piece of equipment or a router or server. So that's the other good thing to kind of remember, is that only certain devices need an address that's static. Static versus dynamic. Do you guys, what's the difference between static versus dynamic addressing?
The dynamic is it's assigned as it's continuously like assigned or something like that, but static will always be the same. So a lot of, I think, companies in the book choose dynamic DHCP or whatever because of the convenience, I think.
Yeah, it's definitely more convenient. So if I have 1,000 computers in a building, I can use dynamic addressing to automatically give those computers addresses, and they're assigned and dynamically means that technically they could get a different address the next time they boot up. So the address can change. Whereas a static address, you actually go into the network settings as an administrator and you type in the address. You know, you assign the address to the machine, and it doesn't change unless you as the administrator change the address. So a static address is fixed. Dynamic addresses can change. So certain things do get static addressing. So in particular, servers, things that you're expecting to find in the same place, and client computers expect to be able to find things like a web server or a file server or something like that on the same address. So and like a website, you would have like a name, perhaps, you know, like a domain name, and you'd have that domain name linked to an IP address, and you don't want to have to change that all the time. So you have a static address applied to your web server. Routers will have static addresses applied to the router interface. So static versus dynamic, we're getting there. You've got public versus private. So behind the firewall, you've got private addressing. That's the other thing about this address, is that it is in fact a public address. 134.39 dot, and this is this is a network address. This is not an address that would be assigned to an individual computer or interface. So we've got a 134.39.00. So you've got all these addresses that could be assigned to computers and things like that. So I'm going to switch this up a little bit. So this is our starting point. This was the network before it got chopped up. I'm using the address for my actual computer in this classroom as an example, so that you can see, you know, if you were in the classroom, we actually assign static addresses to the machines in here. We don't use DHCP usually. We sometimes have that going as well. But this is really unusual in a network setting. As you guys mentioned, normally it's for convenience sake. If I had even 50 computers sitting out here, whatever, having to go to each individual computer and type in addresses and stuff like that. And if something changes, I have to change every single one manually. That's a pain. But they gave me a chunk of addresses for this classroom, which is pretty unusual. So here's our starting point, right? So here's ground zero. And we know that this would be one network. Right now, this number represents one network with 64 plus thousand addresses, right? So 64,000, blah, blah, blah. I forget what the number was, right? It's 2 to the 16th. It's a lot. It's basically a lot. So we've got one big giant network, and this was actually the way it was. They had a Class B network that was given to the network administrators for Washington State, and it was part of what's called the K20 network. So the K20 network shares addresses for a whole bunch of community colleges, and then also the K through 12 schools, hence the name K20, right? So we've got, anyway, you get the idea. A bunch of public schools plus the community colleges, universities kind of got their own stuff as well. So they decided they needed to chop this up, and we're going to give out chunks of addresses to each school. So Wenatchee Valley College got some chunks of addresses. I was lucky enough that they gave me a chunk of their chunk, right? So we got a larger chunk of addresses, and they said, okay, Dave, you can have X number of addresses for your classroom. Now, the trick is trying to figure out what those addresses are. So if I sit down at my computer, which I will do right now, I'm going to open up my good old command prompt. And I'll give me an IP config. So I'm going to share my screen again. So you should be seeing just my command prompt at this point. Okay, so if I run IP config, now you can bring back your last commands by using the up and down arrow. So I can run it again. And I've got several different addresses because I've got a wireless adapter, and I'm also running a VirtualBox, which is or a Hyper-V, which is a virtualization software, which kind of pretends like I've got a little virtual router inside my computer. But what we want is this information right here. And I just highlighted it. So you can see what we've got is my actual address is 134.39.158.14. That's my actual IP address of my computer that I'm sitting at. If you guys are still playing along today in the home game. Then I've got a subnet mask, which is 255.255.120. Oh no, 3255. Excuse me. That's why. And .128. All right, so let's take a breather here for a second and look at my subnet mask. Now, remember that our starting point is Class B, right? Okay. If you just saw that subnet mask and you didn't look at the address carefully, if you just saw that subnet mask, you might assume that that's a Class C network address, and then it has been modified a little bit to chop up a Class C network. Remember our example yesterday? Okay, on Punky's how-to pages, they had a Class C network because it started with 192. And the starting point for that subnet was 255.255.255, like mine. And then they borrowed 5 bits, right? Because they needed to create some subnets. And again, it was a silly example, but he did that on purpose. They said, okay, we need to create 25 subnets, right? And you kept looking at the little cheat sheet, and you're like, okay, that's not enough, that's not enough, that's not enough, that's not enough. If we borrowed 4 bits, that's still not enough. We need to flip or borrow or switch those bits. Remember that there's lots of different terms for it. So you've got the zeros at this end, and we end up having 2 to the 5th is 32 minus 2. Now I was actually still looking, and I know why you lose the 2 addresses per subnet. One is a network address and one is a broadcast. But I was going to look up why. I think it was Kyle, maybe they asked, why do you lose the 2 subnets off the top and the bottom? And I think it has to do again with the network address and the broadcast, but it affects those 2 subnets entirely. So at any rate, you lose 2 subnets right off the bat, and you also lose 2 addresses per subnet. But so our starting point for yesterday's example was a Class C, and then this last octet got changed to 240, right? So 5 bits, 128 plus 64 plus 32 plus 16 plus 8 gives you, I think it was 240 in the example. For our subnet, if you can see this on the board, I'm going to switch back here. So you can, I'm going to get rid of my, because I was just pointing at the board. I can't see it unless you got 2 monitors set up. So let's remember, I've got it on the board already. I have my IP address, as it ends in a .14, 158.14, and then I've got a subnet mask going there. Okay. So again, looking at the IP address, we already answered the first question, which is critical, which is what class of address are we starting with? And several people answered that that is in fact a class B a class B address to start with. And then so we know our starting point, right? So our starting point was what I had on there before. We had a 134.39.0.0 and then 255.255.0.0. This is our starting point for a network. I'll get in there so you can, this is our, yeah, it's a lot of glare. I'll write higher, so, or I'll stand in the shadow. That's our starting point. And then we need to go from our starting point all the way to what's up there. So if our starting point was 255.0.0, we need to look at how we get from here to here. Does that make sense? Okay, so we need to figure out how many subnets did they create. Now I'm gonna give you a heads up. This is one of those ones where it's nice to know how it works, but the numbers are going to get pretty big. So it's also a good idea to use your calculator, or you can also use a subnetting calculator, which I'll show you guys online. There's tons of them on different websites, because ultimately what we're going to look at is how many subnets were created, and then what is the interval? What is the range of addresses for each subnet? And on this one, it gets a little bit tougher because the numbers are bigger, right? If some of you have your calculator out and know how to, we were doing the exponent thing yesterday, you can help me out by doing some math for us. And it's real easy if you bust out your calculator. So if this is our starting point, how many bits difference are there between 0 and 255? Like we've got all zeros here, 1, 2, 3, 4, 5, 6, 7, 8. How many of these bits were changed into ones?
Would it be all 8 of them?
Absolutely.
Oh.
So, right, because 255 is all ones in a row. So for this one, when we're creating subnets, they changed these, all the ones, 1, 2, 3, 4, 5, 6, 7, 8. All of these are already ones, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So you can see a subnet mask. Again, the math is fairly simple when you think about these like switches, and you can't have a switch that's off in the middle of your subnet mask. It's like having a rip in your masking tape where part of it is leaking and you get paint going through there. That's how I'm thinking of, right? So these are all ones, all ones. This one used to be all zeros, and now they switched all of these to ones. And this last one, how many bits do you have to flip switches on to get 128? We look up at our cheat sheet up here.
7.
What's that?
7.
Well,
Or I guess.
it would look, let's look at it this way. If you're looking at it, you're actually looking at it the right way, but so you've got 1, 2, 3, 4, 5, 6, 7, 8.
Oh, I see. Just 1.
Yeah. So I mean, but you're
Okay.
right though. I mean, it's like you're if you were adding all of these numbers together, you'd get the other.
I see.
side.
Okay.
Yeah.
No, yeah, I just flipped it.
Oh,
backwards.
yeah. No, we're on the right track. So we've got 8 here. 8 bits got flipped, or they call it stealing bits as well. So 8 bits were stolen or switched or whatever, and then 1 more plus 1. So we have a total of 9 bits were changed. Okay, so what's 2 to the 9th power? Calculator people, who's on board with me today? Who's got the calculator going?
512?
Did somebody say 512?
Yeah.
Can we get a confirmation on that? I think that sounds right. Okay, so 2 to the 9th is 512. Minus 2 gives us 510 subnets, right? We're walking through the math on this one. Hopefully you guys can see the board. Okay, and then how many bits are left over? If we stole one of these or switched it, how many do we have left over? That's where the okay, so what's 2 to the 7th? It's in our cheat sheet here.
128.
Yes. Okay. So we've got the, remember from yesterday, it's the same formula, but the variable changes. The variable on the first one is representing how many bits were changed to create the subnets. So here and what we're looking at, and this one is weird because when you first look at it, it looks like it's a class C subnet mask. But if you are paying attention, you're like, oh, okay, that's not a class B prefix there. That first octet belongs in the class B range of addresses, right? Okay, so again, just play along, absorb as much of this as you can, because in chapter 3, they'll get into addressing. We're heading that way pretty quickly, but these are good examples. This one came up as a relevant example because this is our classroom environment. So students would normally have to look at this and be like, oh, okay, yeah, we've got, so we started with a class B network. And so we went from all zeros here to all ones. So there's 8 bits there. And then we needed one more bit to make this one 100 to 128. So you can see that changing it to decimal, changing it to binary, to me makes it a lot more visible. Like it makes it make more sense. And on Punky's little how-to pages exercise, you know, he puts these in color too, where he's got, you know, all the ones there, and then these are, you know, these are zeros or in red. So you can really clearly see the dividing line, right? So there's the dividing line between your network portion. And so our network portion has grown. It's gone from 1 network to 510, actually 512 networks. But because of the rules, the subnetting rules, 2 of those networks, the very first network and the very bottom network, are lost. Now there is a thing called 0-bit subnetting. There's also a thing called variable length subnet masks, which we'll briefly get into, but for our purposes, when you're creating subnets behind the firewall, normally you're not using a normal public address either. That's the other thing that's really important to remember, is that our network here in the classroom is really pretty unusual in that we're using a public block of addresses that were already chopped up for us. So like, I'm not creating additional subnets. These subnets were already created, you know, quite a long time ago. And they said, okay, here, Wenatchee Valley, you can have several of these subnets to play with. And they gave me one of them. So one of the things that we'll have to figure out is we've got 510 subnets. That's a lot of subnets, right? That's, I mean, and then maybe Wenatchee Valley College got 4 or 5 or 10 of them or whatever. And then we'll have to figure out, okay, what are the addresses that are in each subnet, right? So I've got a .14. Now this might come up in, you know, if you're at a job and you sit down at a computer and you run ipconfig, you're going to get an address for that individual computer. And then you also get a subnet mask. And then you can kind of look at it and you can figure out, okay, what other devices are going to be in this range of addresses, and you can scan the network, stuff like that. I'll run an IP scanner and you can see. So this is where a subnet calculator comes in handy, because the numbers, you know, you think about it, we've got 65, almost 64,000 addresses. So 64,000 addresses, and we've all of a sudden divided that up into 512 subnets. We're losing a couple of them, but we'll have 512 to start with. And then each of those subnets is going to have this many addresses. So 128 minus 2 equals the number of hosts. And that's probably right in the glare, the number of hosts per subnet. So 126. So we have 126 addresses in my network here in the classroom. And that's what I needed to find out when they actually switched addresses on me a few years ago and gave me a new block of addresses. So then because they made some changes to the routing and stuff. So then I had to figure out, okay, which addresses do I have? Which ones can be used? So if you look at on my command prompt back there, one of the other things was my subnet mask. I'll try to write that. My subnet mask was 134, or not my subnet mask, my gateway, 134.398.39158.1. So my gateway is a .1. And remember, the gateway is always the first usable address in your subnet that's available, right? .0 is not available by default. And then .255 would not be, but that 255 actually happens to be in another subnet, right? Because we only have 126 addresses. So we have from a .1 to .126, 127 would be our dividing point. That's going to be our network address. So I'm going to fire up a subnet calculator so you guys can see how this plays out on a subnet calculator. And you'll see, okay, here's all the blocks of addresses. And then we can find, okay, there's our subnet hiding right there. So I'm going to try to find one. I had one that was probably not on this computer. I'll just look them up online here. There's lots of them, and you guys can be looking up subnet calculator. First one that pops up, online IP subnet calculator. All right, so I'm going to share my screen here. And you guys can be playing around with these at home too if you want. So I'm going to switch the subnet calculator to class B. And now notice, I'll make this bigger so you guys can see it better. You guys should be seeing my screen at this point. Thumbs up, maybe. All right. So notice that class B changes to a 172 address. That is the private address for that people would, now remember, most of the time you're using private addressing behind a firewall. So class A is going to give you a 10 dot address. Class B would give you 172, and class C would be like your home addressing and be 192. I'm going to change this to be class B, and I'm going to put in my own address. Whoops. Okay, so oops, .0.0. Okay, so there's our starting point. And now our subnet mask, you can see also the other thing to take note of in our subnet mask is notice how they're using the same numbers over and over again. And that totally makes sense, because if you think about if you're switching bits, you're going to have like 128 plus 64, or 128 plus 64 plus 32, or those three plus 16. You know, as you keep switching those bits, there's only certain numbers that are ever going to be possible, right? So one quick heads up, if you guys are ever taking some certification exam or test question or something like that, and it has, you know, if it's multiple guess, if you're guessing, sort of guessing, one thing you want to do is rule out stuff that's wrong, right? If there's possible answers that are wrong. So if they ever have a subnet mask that has like a 225 in it, or a 237 or some weird number like that, you know that's not a valid subnet mask, because they're all going to have the same numbers. You can see it repeating here, 192, 224, 240, and down the line, right? So there's only certain numbers. They're always going to have 255s at the beginning part. So if it has a 254 in there or something weird, that's not a good number. And then as those numbers get switched, so here we can go down the list and we can see that this subnet mask, the one I've got highlighted, is the one that my classroom's been using, right? Are we on the same boat so far? So the boat's not sinking. All right. So there I've got my subnet mask. Subnet bits, it automatically filled that in for me because, you know, we had the 8 bits that got switched plus one more makes 9 bits. That's the 2 to the 9th thing. Subnet mask bits is that's a /25 address. So if you were looking at this subnet mask, it would be /25 because you've got 8 plus 8 plus 8 plus one more. That gives you /25 in CEDAR addressing. You can see the board. So maximum subnets, we were right on with that. So whoever said 2 to the 9th power was 512. And then the other end of that, 2 to the 7th power, was 126. So it gives us a pretty nice little range there. Now, this one does not show me all my individual subnets. I wanted one that did here. I might have to find a little, let's see. Nope. All right, so this one doesn't show me, I wanted to show me the individual subnet, so I might, but you get the idea. This one will show you a lot of what you need. I had one before that was better than this. Let's see here, maybe this one will. Okay, so this one's detecting my IP address that the computer is on. There we go, and okay, so this one detects my address and it shows me my subnet range, and that helps too. So some of the subnet calculators will you'll actually be able to break it out and it'll show you each subnet. You can scroll down the list until you can find the subnet that you're actually in. This one just shows me my particular subnet, and that's helpful as well. So from a networking perspective, if you were on a network, you would know that, okay, here's my gateway. My gateway address is the first usable address within that subnet. And then I would know the top number too. So if I start, and what happens here in the class, if I start assigning addresses, you don't want to assign the same address to two different things, right? What happens if I had the same address on two computers or two network nodes? Because it could be a printer or something too. What happens with the same address on two things?
I imagine all the protocols would get messed up and it'd just be a kind of a mess and just bad traffic.
Yeah, I mean, it's yeah, they call it a duplicate IP address. So if you have two things that have the same exact address, now that doesn't happen hardly ever with DHCP, right? That's another advantage to using the dynamic host thing, is that you've got something giving out addresses and it's probably not going to give out the same address to two different things, but it can happen if you have static addresses, right? So if I've already given a static address, let's say to this printer, and we start using DHCP, but I forget to put in an exclusion. So you can put in an exclusion to say, okay, don't use that address because I've already used that for my printer. That can come up. On your networks, when you guys are trying to troubleshoot stuff, this is a quick one as well. If you're trying to troubleshoot stuff and you'd run ipconfig/all, and you see here where it says preferred, if it says duplicate there, then you know there's a problem. You know that there's a duplicate IP address on the network. Now, Windows 10 used to actually, before they made some changes to it, in Windows itself, it would pop up, like you would log into the computer and you'd get a warning message that would pop up and it would say, warning, you know, a duplicate IP address has been found on the network. For some reason, it doesn't do that anymore. So in class, if we were trying to troubleshoot stuff, we would get duplicate IPs every once in a while if somebody didn't follow instructions and put the address in, or a wrong address or whatever. So then you'd have to start troubleshooting and you'd run an IP config and you'd see a duplicate there. Now, the hard part is trying to figure out what else has that address. You know, it's pretty difficult to try to determine what the other device is that's stolen your address. So you might fire up something like an IP scanner. Now, this is one that you guys can run at home. Was it this class or the security class where we were talking about scanning networks? We do it in the security class. Did I mention it to you guys too? Brandon was talking, but I don't know if he didn't have his microphone on, but yeah. Have you guys seen Angry IP Scanner yet? Okay, it's nothing super exciting. You guys should be seeing it on the screen at this point. It is automatically detecting my IP address and my starting and ending range. Now notice that it's starting at .0, so that's that's the network address, and then 127 is the broadcast. Under tools, under preferences, you can tell it to scan in different types of scans. So the first one is Windows ICMP. So when you get in, when we start talking about protocols and different ports and stuff like that, this will make more sense. But ICMP is Internet Control Message Protocol, and it's used for pinging stuff and doing other stuff like that. Things like a printer might send out ICMP messages. So I'm going to go ahead and click start. And it's pretty small on your screen, but you guys can download this Angry IP scanner, and you guys could scan your own networks at home behind the firewall. And that'll help you determine what else is on your network. So like, I don't have much stuff turned on right here. It's detecting the gateway. There's my computer down here a little bit further. If I could make this bigger, that would help. It doesn't zoom in like a website would. It's just, so then I've got a .49 that's popping up. .71 is popping up, because most of the computers in my classroom are turned off right now. So it scanned 128 addresses very quickly, and only 6 reported back from the ping sweep. Now, some computers will not reply back to a ping request if you've got even like a regular software firewall going, for security reasons, because hackers use tools like this too. If you're on a network and you're trying to figure out other computers that are on the network that you might want to like take a look at or hack or whatever, you're going to be footprinting the network using something like this Angry IP scanner. So here you can see it's got .99. That's our file server that's in the back of the classroom. And that's about it. You know, if I had all the computers turned on, we would be seeing a lot more of these come back with live, you know, that there's a live host at the other end of that little ping that goes out. So that's called Angry IP scanner. And you can Google that or look it up, Angry IP scanner. And it's from angryip.org. Easy to find. To make sure you're not downloading it from, you know, some Russian website with weird pop-ups and viruses galore. So Angry IP scanner, it's a free download. So easy to use. It detects your own IP address as well. Make sure it's not trying to scan out, you know, everywhere in the universe, but it should just be scanning your own range of addresses for your own subnet at home. So that's a good little quick. What's that?
Should I download it from LimeWire?
You can get it from directly from Angry IP itself. No, not Lime. Oh, you were joking. Yeah, not LimeWire.
Yeah. Unless you want to wait 9 hours.
Yeah, no LimeWire. Is LimeWire even around anymore? I didn't think.
It might be archived somewhere, but
Yeah, that used to be the MP3 downloader of choice, right? For getting.
yeah, that's
Bear share.
BearShare, LimeWire. Oh man, you're giving me like flashbacks to the 90s. Yeah, totally. All right. Okay, so what you want is the 32 64-bit installer, and it might ask you to update Java as well. That looks like there's an older version here or just an executable that you can run. But I downloaded the 32/64-bit installer, and it's a tiny little program. It downloads really, really quickly. So, and there's lots of others out there, but you know, you do want to be careful about downloading tools that are. So here's the deal. I mean, a lot of times they'll be called quote unquote network information tools or network scanning tools. Now, if you're scanning your own network, that's cool. If you're scanning somebody else's network, then that puts you in the evil hacker category. So a lot of these tools are used legitimately by IT people, network admins, network security people. But the same tool, if you're trying to scan somebody else's addresses, that's a whole different ballgame. So you do want to be aware of that. And then if you're scanning your own network, that's great. Try out different types of scans under the tools, under preferences. So give that a try. We're going to be wrapping up subnetting pretty quickly. So if you didn't, you know, I think most of you were here yesterday. I put this on the, excuse me, on Canvas as well. But here's Punky's how-to pages. Try to walk through his exercises and make sense of it. So if you can make sense of what he's talking about, and he does a pretty good job of explaining it. So he went over subnetting a class C yesterday. Today, we looked at a class B network example. So you always have to figure out what network you're in, what class of network, and what your starting point is, and then what your ending point is, if you've already got an ending point. Now, if you're creating subnets, then you make up your own subnet mask. And you'd say, I want to make, you know, if I don't want to make 512, maybe I want to make 256 subnets or whatever the case may be. Okay, we're about done for today. I appreciate your attention, and I like the questions and feedback. Just hoping to get more of that too. So we'll meet back here on Monday. I'll probably, you've got a quiz that's due tomorrow. So finish your quiz, just 20 questions. We'll have, keep an eye on Canvas. You might have some other little things to play with. Like I'll post a link to the Angry IP scanner and stuff like that. So you can test out some of this stuff on your own networks. Okay, questions?
No, I just want to be a little bit more engaged. So maybe through Discord, I'll ask some questions, because you know how this information goes. Like I see it, oh, it makes sense. But then all of a sudden I'm like, oh shit.
Yeah, no, for sure. And you guys, when you guys are posting on Discord, open it up. I've had quite a few people sending me a direct message on there, which is cool. And I don't mind replying at all. But if you open up the questions on like the broader class discussion thing, you might get other students commenting back as well, which is really nice to get a little bit more discussion going back and forth between you guys. So, all right, yeah, very good. So we'll catch up, take a quick break. Some of you are coming back at 10. So we'll see you guys here in a few minutes.